Alright, so here we are doing the 5/8 notes. We're applying special right triangles. In fact, a 45, 45, 90, meaning those are the angles of the triangle, and then a 30, 60, 90 triangle. The idea is that once you get to these special triangles, you can actually do this without having to do a lot of the Pythagorean theorem, and actually you can have less data in order to solve them. So taking a look at our first one here, we are using a cursive L here for a length of a side. But the idea is that if you have a 45, 45, 90 triangle, which means that it is an isosceles triangle, you in fact have two side lengths that are the same. That's fine. And if you take that length and multiply by the square root of 2, you actually get the length of the hypotenuse. So, interesting part about this as well is that it does come from half of a square. So if you take a square and put it in half, we do know it's diagonal, or if we knew it's diagonal, we would know what sides it came from. So that's your 45, 45, 90 triangle. So the idea here is that we see that this is a 45, 45, 90 triangle, even though they don't mention that this is 90 degrees, but hopefully we know that the little box means 90. And the fact that either, because we remember this 45, or we subtract from 180, we realize that 180 minus 90 minus 45 actually leaves us with a 45 over here. So we have a 45, 45, 90 triangle. In reference to the triangle that we were given in the previous page, that means that this is our L, and this is our L square roots of 2. So based on what we have here, that means that L is 8, right? Those match up. X, the thing that we're solving for, is L square roots of 2, and then we're not actually even talking about this one here, but we do know that it would be the same length as 8. So, in that case, L equals 8. And so, if X, what we're trying to find, is L times the square root of 2, that means that I just need to put in an L of 8. So we have 8 multiplied by the square root of 2, and that's just a digit, so 8 times the square root of 2, and that gives us 11.3137. So again, we were only given one side length and one angle, well, two angles, and so from that we were able to then find all the rest of the sides and not even use Pythagorean theorem. Alright, our next idea here is presented with another isosceles triangle. It's got a length of the hypotenuse of 5, and so this one is now going to move backwards. So it's the same thing as our previous, only rotated as our previous idea. So this is our length, this is our length, our legs, and this is the hypotenuse, which is L square roots of 2. And so potentially X is L, which we can see, but then 5 is L square roots of 2. So if 5 equals L square roots of 2, and X equals L, we use our first piece to solve to find what L is. Well, if this is multiplied by the square root of 2, then let's divide. And then whatever that decimal is going to be L, which is X. So 7.0711 is going to equal L, and that equals X, and so 7.0711. So you're always looking for your reference triangle, that's what we like to call these ones, and how it is oriented to get the image that we're looking for. Alright, the next one is a 30, 60, 90 triangle, and of course, just like the previous one, this one now has a 30-degree angle, a 60, and then a 90-degree angle. And then from there, we're able to find out the lengths of our sides. So we've got this smaller angle across from this smaller side, which is just represented by S. The hypotenuse is actually 2 of those S's, and then the height is actually that S times the square root of 3. So this one is going to be a little bit more difficult to orient than the previous one, but it is still going to be something that you draw the matching triangle for and then set those sides equal. This actually comes from an equilateral triangle that's been cut in half. So it turns out if we recreated this, we'd have a length here of 2s, we'd have another one here of 2s, and so we'd have an equilateral triangle. So this is the altitude of that equilateral triangle, and now we have a 30, 60, 90. So taking a look at our first one here, if we orient the triangle that we had on our previous in the formula, the shorter side is s, the hypotenuse is 2s, and then over here we have s square roots of 3. So setting up what that equals, 22 is going to be 2s. Got to watch out for your s's because that's an s and not a 5. Our x is going to equal this side length here, which is s, and our y is going to equal s square roots of 3. So to solve, we can start with that 22, because 22 is the only one that's a number, and that's going to equal 2s. So how do we get s? We divide by 2, and we get an 11. So now that we know that 11 is s, now we can actually find out what x is. So we said that x equals s, and s equals 11, so x equals 11. The other one says that y equals s square roots of 3, and of course s is 11, so it's going to equal 11 times the square root of 3, or the decimal of whatever 11 times the square root of 3 is. Whoops. Type that in wrong. Alright, 19.0526. So we know what y is, and we know what x is. So you're always looking for that reference triangle, and then kind of matching up your sides. Alright, the next one, we're again with 30, 60, 90. So I'm going to draw my reference triangle. That shorter side is s, the hypotenuse is 2s, and then that height there is s square roots of 3. So if we match them up, that means that s square roots of 3 is actually 15. So in order to get our s, we could divide by that square root of 3 and get an s value of 15 divided by the square root of 3. So 8.6603. Now that we know what s is, we can go ahead and apply that to, for instance, x, because x is supposed to equal s, and s is 8.6603, so x is 8.6603. And then our y is supposed to come from two of those s's, so if y equals 2s, that's 2 times 8.6603. And so that means that our y is equal to 17.3205. So hopefully you get the idea of making the reference triangle match the triangle that's given in the problem, and then set your sides equal. Alright, so a few more, kind of again just practicing this idea. I can see that this one is a 30, 60, 90 triangle, so I'm going to set it up where s is that shorter side, 2s is my hypotenuse, and s square roots of 3 is this bottom side. If I set them equal, at least one of the first numbers says that 2s is equal to the square root of 6. So in order to solve, we divide by 2 and get an s of the square root of 6 divided by 2. 1.2247. This is also a formula, these images here, that is often given in your MCAs or standardized tests, placement tests, things like that. So it'll be something that you'll see on those formula sheets, and so it's just something that you can use if you feel like it, but of course there are other ways as well, like we could use trig to solve this, which we will get to later as well. So If s is 1.2247, we know that x is s. So x equals s, and s equals 1.2247, which means that x equals 1.2247. Alright, and then our last one, y is s square roots of 3. And we know that s is 1.2247. And so we need to multiply that by the square root of 3. And we get our y value. And so we have 2.1213 as our y value. Alright, the next one, again, we know it's a 30, 60, 90 triangle, and so this time I'm actually going to write our equations on it instead of a reference triangle. So this is going to equal s because it's the shorter side. This is going to equal 2s, and this is going to equal s square roots of 3. And so it's very easy to see, hopefully, that if this is a square root of 3 and this is a square root of 3, that s is actually 10. From that, we know that x is 10, and then we know that y is 2 times 10, and so it's 20. So sometimes it's easier to, instead of drawing the picture, sometimes you can just put the pieces next to it. So either way, great strategies. Then we have some more practice, but as you can see, these ones are both 45, 45, 90. So going to back what we had before, I'll draw the reference triangle for this first one. And so this is going to be L square roots of 2 for the hypotenuse, and then your L's for both of these sides. And so we know that L equals 5, but if we want x, x is equal to L square roots of 2, and so 5 square roots of 2 is our x. And so 5 times square root of 2 makes 7.0711. Alright, and then this next one here, I'm going to do it the other way. So now I'm going to say that it equals s square roots of 2, and then this equals L. Oh, it's not L anymore, it's L square roots of 2. And so in order to solve, I'm going to divide by that square root of 2, and realize that L is 9 divided by the square root of 2. 6.3640. And of course L equals x, so x is 6.3640. Alright, the last ones don't give you images, so this is always a little bit more difficult, but anytime they don't give you an image, you are going to want to draw it. So this one here is a square, and hopefully you can realize that, going back to our notes, a square divided in half gives us our 45, 45, 90 triangle. So taking a look at the problem that they're giving but not giving, we are looking at a 45, 45, 90 triangle with a diagonal length of 20. And so we now know that 20, the diagonal, equals the formula of L square roots of 2. And so if we want to find the side length, which is L, we would just divide by that square root of 2. And we'd get an L of 20 divided by the square root of 2, which is 14.14. And since it is a word problem, they want centimeters. Alright, the other one says that an equilateral triangle is formed. And so remember, an equilateral triangle, when you cut it in half at its height, you have now formed a 30, 60, 90 triangle. And so it's saying that its triangle height is 24. And so we know that that is the side that actually equals s square roots of 3. So we know that 24 equals s square roots of 3 from our formula. And so if we want to find base and side length, of an equilateral. So if we want to find the base, that's going to be our S value, but then 2 of them. And then our side length, which is just going to be 2s. So all of them, we just need an s to multiply by 2. So to solve, I'm going to divide by the square root of 3 to get the s value. So 24 divided by the square root of 3 is 13.86. And then, of course, that needs to be multiplied by 2 in order to get the side lengths of your equilateral triangle. And so times 2 gives us 27.71. But I guess if you already rounded, 7.2. And we are talking about inches. So this is the base and side lengths. Alright, so that is what we were doing in these notes. So again, referencing these triangles of 30, 60, 90, and then their matching sides based on a unit. And then we also have the 45, 45, 90. Again, looking at the reference of the sides of that isosceles triangle.